a lot of noise.
Okay, so I just started now the streaming on YouTube. The channel is the same as the other days, and it's especially addressed for external people, colleagues and students. I discovered today that also the YouTube transmission are actually recorded on the YouTube channel. So if you are more comfortable to go on the channel on YouTube, we will distribute also the link of the playlist. We are making a playlist with all the webinars for all days. Although if you watch the movie, if you watch the recordings on Zoom, you can also download it. You can hear if you want the double speed, and I think also you see synchronize the chat there. So probably it's more comfortable to watch it and to hear them on Zoom. So it's 11, and probably we can already start to record the meeting. Let me start the recording. Okay, we just started also the recording, and also let me project, before giving the floor to Michelle, let me just, while we are waiting, project the program for today. Do you see the full image? Yeah, okay. So today is the multidisciplinary webinar for Curriculum 3, Technology and Territory. And this is the program that I think Michelle will illustrate for the morning session, and Michele D'Assisti will illustrate in the afternoon sessions. They will be your chairman for these two sessions. And as you see, for the morning, after the introduction by Michelle, we will have three presentations given by different speakers, and at the end there will be a discussion, probably led by Michelle, right, Michelle? So you can either write your questions in the chat if you want while you are hearing, in order to avoid to forget them, and also participate in the discussion at the end. So given we have a long program, I suggest that we can start, but before, let me just present Michelle. Michelle is a colleague, a friend. She's a very active member of our PhD board. I thank her very much. She's an associate professor in town and country planning at the University of Brescia, and the director of the Research and Documentation Center for the Agenda 2030 at University of Brescia. My scientific research field is on sustainable development strategies applied to spatial town planning tools, integrated spatial planning policies for resilient city, open spaces renewal applying to resilient city concepts, and accessibility and road safety of urban environments, focusing especially on vulnerable road users. So I really personally thank Michelle for her important contribution to this PhD, and let me give to Michelle the floor to present the program for this morning and introduce the webinar. Thank you, Michelle.
Thank you, Mario. Can you hear me well? I think yes.
Very well.
Okay. I have organized a small PowerPoint presentation also for the introduction, only to keep the time and give you short instructions. So I will share the screen, so you can tell me if you can see everything in this short speech. Are you able to see the screen? Wait a moment.
Yes, we see it very well, Michelle.
You can see the entire slide.
Yeah. You can preview, make the You can probably do the full screen mode.
Oh, you can see the full screen.
No, we are not seeing the full screen. We are seeing just normal editing mode.
Wait, sorry, one moment.
Yeah.
I'm not so user-friendly using Zoom, so...
You can first start the preview mode, the presentation mode, and then when you share the screen, you can select the picture with the full screen mode. In this way, you are sure that you
I share correctly.
Yeah, exactly.
Wait a moment.
Okay.
I'm not able to do that.
Or just share that screen and after start the preview mode. We probably can see it.
Wait.
Yeah, no problem. In the meantime, let me ask again if anybody of you experienced problem with the technical problems with the learning test. Did you have problems to do the test? No? Okay. And did you access to the recordings of the previous day? Any problem with that? No? Okay, very well. I upload now the link also for yesterday, the afternoon session of the webinar yesterday. All the webinars, I have to say, were very, very interesting. Michelle, you can now press the presentation mode on the lower right corner, close to the Zoom bar.
Not, it doesn't work.
Okay, but we can see it very well. Okay, now we see now you go on impostazioni di visualizzazione, sopra, yes? No, right, a destra, impostazioni di visualizzazione. Quello che c'è sulla barra in alto, impostazioni di visualizzazione.
Impostazioni di visualizzazione.
Sì, lì proprio sulla barra in alto, non so se lo vedi, perché noi lo vediamo in modalità presentatore. Vai su, esatto, impostazioni di visualizzazione.
No.
Ecco. E adesso metti modalità switch, fai lo switch.
Non ce l'ho.
Ah, ok.
Sorry,
Sì. Oppure prova a fare, adesso che hai fatto modalità di presentazione, vai di nuovo su condividi schermo, share the screen, quel tasto verde, e seleziona la finestra dove hai l'immagine aperta, completa. Ecco, perfetto.
Sì. Oh, ok, sorry.
Okay, that's
okay. Because I have several notes and the images is so it's bigger. Only a few words and notes. Mario already introduced the curriculum, but I want to underline only several aspects in relation to this curriculum, because it's related to our point of view. The main focus of the curriculum is our technology systems and the approaches in relation to transition of communities, territories, and production processes. And our point of view is quite interdisciplinary. Okay, we are one of the biggest curriculum inside the PhD, and we are coming from different discipline sectors, from architectural sector to engineer sector, also from physics and chemistry. This is a specificity you need to have in mind while listening these presentations. And we decided to organize the presentation divided in two parts. In the morning, I manage the first, as the chair of the first part, and we have a presentation that are more related to the territorial aspects. So we have a broad introduction of the problems related to managing sustainability, modeling, doing analysis at territorial level. And in the afternoon, we have we go through the knowledge inside the more specific disciplines and sectors. Why we decide to organize the seminar like this? Because we have two aspects that are really interlinked each other. And to transform research into action, into practice, it's quite important to work together. So we are really an interdisciplinary and multidisciplinary group that is trying to provide solutions to sustainability transitions and provide solutions to be applied in real case studies. Which presentation are we done today? The first presentation is a bigger introduction provided by me and Francesca Pierloni. We focus on planning. And I talk for the guys that are not involved usually in the planning research field. You must understand the importance of the planning action on the territory. Territory is not a platform on which you put things, but it's the result of a vision, a technical vision, but also of the social vision. And is the planning action is the art to put in practice policies and visioning in real life. The other two speeches, the one done by Giovanna Grossi and Alessandro Capra, and the other done by Motta and Marzan, focus more, reduce the spectrum, and the first focus on the water resource problem, especially in the management of water resources in the existing real territories. The other presentation will focus on modeling tools. Modeling serves practice. We have to do to improve models, and technology supports our capacity in improving models to support the transitions. So only a few suggestions and an operational point of view. I'm so sorry, but probably I know that we will not be able to reply to all your questions. So I suggest please write them in the chat. We try to manage the answer in time, and also your question will be really useful, I think, to organize next seminars inside the curriculum, to share knowledge also among the curriculum. And please feel free to contact also my colleagues and me if you have, if you want us to provide you literature, something to read, to deepen research field of your interest, because you are so big number of students, and I think you have different interests. I move to the other presentation. I think I have still my screen shared. Are you able to see the presentation in the full screen?
Yes.
Yes.
Thank you very much. I do the first part and Francesca Pigloni do the second. I am focused, my presentation is focused on cities and sustainability. The first slides are a bigger introduction to the topic, but you must be aware of the phenomenon of urbanization. You find this slide, this figure in a lot of public policy books, and it's well known. But you must be aware that one of the biggest phenomenon of the 21st century is urbanization. And cities change a lot in size, in form, in structure, and in composition during these years, and experience a great expansion. In just 65 years, a short time, really little time, the world population shifted from rural to urbanized areas. And this phenomenon doesn't stop yet. We moved from, in urban areas, from 29.6% to 54% in these 65 years. And we expect that 70% of the people in the world will live in urbanized areas by 2050. The question to be understood is why cities are so fascinating people. Human nature develops at the first beginning from the basic need of searching for food and shelters towards a more complex needs of creativity, drawing synergy from involvement in different activities. And nowadays, our cities are productive systems, drivers of innovation and development hotspots of technologies. They are places of investments, places in which research is done, and they are attractive places for talents, but also for people that are searching in opportunities. You must be aware that the phenomenon of migration is a big phenomenon. And then they are also a place which there is a mix of knowledge, culture, ideas, creativity. So this is the point. So cities are the house of our society, the biggest house of our society. But cities, despite of this, from these opportunities, cities generate also a lot of negative impacts. These impacts go beyond the boundaries of the cities and are in all the territory. Since the Industrial Revolution, in fact, urban centers have concentrated industries, constructions, transportation systems, households, and we realize inside the cities a large quantity of greenhouse emissions, but also solid and liquid waste. And we have to manage this entropy that we generate inside the city. Urban development is the first cause of deforestation, land cover changes, and this important negative consequence have an effect on soils, ecosystem. You are aware of this aspect because you are doing this PhD. You choose this PhD, I think, to contribute in solving these problems, which is another problem of cities. Cities become also place of big places in which poverty, inequity, spatial segregation is concentrated. This is the result of a poorly planned urbanization. This is a point from my point of view as a planner. A result that can be seen by society in the huge slums, in the tangled traffic, and greenhouse gas emission, and in sprawling inside suburbs all over the world. Being aware of this, we have to better understand city impacts, because city impacts go beyond the geographic location, go beyond the city borders. And it's evident that we are unable in practice to solve the problem through planning, city planning and city policies. This is one weakest point. When we have technology at disposal, when we know that city has generate impacts outside the boundaries in the territory, we aren't unable to manage correctly the phenomena. To cope with this impact, it is important to understand how city works. Cities are a complex system. We must be aware that sustainable development topic add an element of complexity, of tension, inside the process of urban development. In political terms, the need for sustainable development should be seen alongside the need to address economic and social issues, such as unemployment and social exclusion. What does it mean? That sustainability, it isn't a topic aware, separate regarding planning, spatial planning. It is fundamental to assume that policies for sustainable urban development need to place economic and social analysis at heart. In the same way, policies for urban and economic and social restoring need to have environmental consideration at heart. These are two aspects of the same problem in planning policies. A sustainable city cannot be rooted in an idealized version of past settlement. We have to avoid this hypothesis of solution. And a sustainable city nor can be an idealized, cannot be an idealized vision of an unattainable future, because we need to act to move from the theory of sustainable cities to practice, to plan sustainable cities. And this is quite complex to be realized. We have example of sustainability, of sustainable cities, of sustainable communities, but there are too few in real life. The starting point, you all know which is the starting point. We have consolidated documents, consolidated visions. We know that our common future is the first step. Now we have signed the 3030 agenda that SDG, Sustainable Development Goals, Goal 11 is on sustainability of cities and territories, but we have still difficulties in solving these problems, in planning problems. We have a lot of problems. I want to share with you this document that is the Basque Declaration. That it was signed by 40 countries in 2016. What Basque Declaration highlights? It highlights that we need ambitious local leaders to think to think outside the box and find innovative ways to engage civil society in order to meet economic and environmental and social challenges to solve problems of our cities. So we need strong institutions, strong politicians, strong to boost transition. Why now we have understand that we have complexity of urban system and systems, and we have to understand also the importance of spatial planning to reach the global sustainability. I used to cite this phrase, this document that is, I think, quite important. We will won or we won the sustainability in the cities. We cannot avoid this. I want to share with you 3 stories of success. One is a story of Copenhagen, only a few words. The city of Copenhagen has a long story in sustainable development. What happened? They started and then they monitored the results, and now they propose interdisciplinary approaches. At the moment, they are provided integrated planning policies related to transportation systems, urban redevelopment, climate change, renewable energy, green spaces preservation. Due to this capacity building of integrating policies, they won the European Green Capital Award. If we give a look to Copenhagen, they invest also in projects that go beyond the boundaries of the city with a regional view, and they invest in, cycling is important in Copenhagen, is why the most common modal split, and they realize the cycle superhighway, improving the capacity of their network, and increasing the 23% of the number of cyclists, because the modal split of cycling is used to go to work, and many people live outside the city of Copenhagen. So it's important to be open in mind and integrating public policies at different levels. Another story of success is from Copenhagen, from Tallinn. And Tallinn has showed recently a growing systematic approach in the transition through to reach sustainability, and they have built an interlinked strategic approach that address carbon neutrality, climate adaptation, innovation, health, mobility, biodiversity, circular economy, sustainable energy, and food production. So an holistic point of view to reach results. Giving a look to the document related to Tallinn, we focused on sustainable land use. We can see a prioritization of action from the landscape, from the spatial planning process, from the point of view of the spatial planner. And you can see that the densification, but also mixed-use development, renovation of brownfield, are connected also to landscaping, and also technical aspects like introducing permeable surface to help to manage storm water and to solve rainfall problems are addressed inside the document. So technical and political aspects are joined in a strategic vision. This is another story of success. It comes from China. I select the city, sponge city concept because present a story of experimentation. They decide that they have a problem. The problem is flooding, and they decided to try to change out their cities, experimenting and proposing new development, new solutions. This solution put together technological solutions, engineer solutions, together with natural solutions that are nature-based solutions to help cities, and they transform the green solution. You can see there a wetland that is the result of the solution of the technical problems that is a nice outdoor space inside the neighborhoods. So this is the result of a planning theory applied to real life. So we have a wide spectrum of urban planning, but the planning process must involve all the society, because the end users of our design are people. And it's not only a technical issue or a technological issue, but we have to have in mind that many technical problems are behind the planning process and the solution proposed. So we can make our framework a little bigger. If we cope with sustainability, we have in mind, we need to be aware that sustainability in behind at the moment have a wide range of perspectives. This range of perspectives that can be green cities, low carbon city, circular city, a lot of these are related to the sites, the context. The city context has a great influence on the possibility of the possible solution. So from theory to practice, we have the real context, the morphology, the characteristic of the territory, but also the specificity of the society, of the economical level, of the economical context, and we can boost several solutions instead of other that cannot be applied in a specific context. These perspectives are interlinked by this lane, and this interlink is represented by our technological capacity, our smartness in proposing solutions applied to real case studies. So we need to experiment solution, monitoring them, build vision through scenarios, but we need also to engage society in the possible solutions, which is one of the most important problems we have, is that we aren't alone. We are inside inside the world, and we are inside also an organized political context. So we have vertical policies that comes from the top, from the European level, for example, and goes down to the local level, and right to the local level, and You can see the problems of interlinkage become bigger at local level, because the society is more active at local level. It must be engaged at local level, because the problems must be applied and solved there in a specific context, in a specific territory. So we must be aware of the most common barriers we have that are summarized in this slide. The lack of technology. The lack of technology in that context, in a specific context. Smartness is the ability of apply the right technology in a context. In a Japanese city, you can apply a technology. In a small country or in Africa, you cannot apply the same technology. We must be aware of this. Then we have lack of knowledge and competence at the local level. In several, we have a lot of problems in these topics because in some cases the politicians have a lack of knowledge, and they need to take decisions. Then we have also a scenario that is have disorganized funding, disorganized political uncertainties, and we must to we need to provide solution. The last consideration, and then I pass the floor to Francesca. This slide is the redesign of a scheme done in 1989. It's quite important because if you think that cities are here, we reach in the first slide. I tell you, we reach a peaking now. The cities grow, and we are in the decline of our systems. Give a look here. Infrastructure we need. We have the problem that we have infrastructure under investment. We need to change, to improve, to restore our infrastructure. Now we have the relic land phenomena. It's real because the land use changes. So a lot of land is abandoned due to the changing also of the technologies. We have social stress, and cities are the places in which this social stress are concentrated. And we have a lot of road congestion still. Policy instruments, look, develop more resource-efficient technologies. We were in 1989. Public transport, we need to change our public transport, make them more efficient, treat them as services for citizens. We need to work on user pay charge. This is another aspect. We need to develop strategic land use planning. This is my research topic. And we need to work on land use controls more, better, in a renewed way. 1989, 200, 2022. What changed? This is the reflection. I want to live with this. This means that society have it's difficult for the society to change. We need a change. We need to provide solutions, but we need to be aware that we have no time left. We need to accelerate, we need to boost, and this is difficult. We can reach the results only through experimentation, applying theory to practice, and find site-specific solutions. I stop myself. So I don't know if I'm able to give the screen directly to Francesca.
Okay, thank you, Michelle. Can I try? Okay, my presentation. A moment, please. Okay. Thank you, Michelle. Good morning. I'm Francesca Perlone. I'm a professor in urban country planning at the University of Genoa. I am a member of a working group of Sustainable UNIGE, University of Genoa, and I'm a UNIGE contact person on the subject of the circular cities. In my presentation, in this second part of our contribution, I would like to present to you the circular city. So the circular city is an important theme within the more general theme of sustainability. The colleague, Professor Pessagno, has already introduced this aspect. In my contribution, I would like to focus on the four questions. The first is, what does the term circular mean? And what is the circularity? The second is who introduced the circular city? The third, what is a circular city? And the fourth, the last, is it possible to transform our cities into circular cities? Now, let's try to answer to the first question. The concept of circularity is within the concept of the circular economy that was born in 19th, also in connection with the reinterpretation of the concept of waste. Since the 90s, the concept of waste is a change, which is no longer seen as a negative thing to get rid of, but as a resource. Even the best waste is that which is not produced. So attention to prevention in this field is also fundamental. Since 2008, the Waste Framework Directive has been introduced. This directive introduced the hierarchy of waste order of priority in waste management. In this upside-down pyramid, we can find the letter P as a prevention, and R different R as a reduction, R as a reuse, R as a recycling, as a recover, and the letter D as a dispose. There are no sustainable landfills. This directive introduced the concept of R and the basis of the circular economy. Before the 19th, linear economy existed international. The linear model was production, use, and disposal. Every product is intended to become a waste. There was an intensive exploitation of resources. Then we move from a circular economy to a linear economy, to a circular economy. A circular economy is an economy able of promote global competitiveness, strengthen sustainable growth and generate new jobs. It is very important the elaboration of fact sheet circular economy package in 2015. First, we have 3 R as reduce, reuse, and recycle. And then we arrive at the 5 R, reduce, reuse, recycle, and recollect, and recover. So how many R's are there today? Always 5. In this slide, I report 8 R, but in literature there are you can find N R. I like this classification because it introduces new R's, different R's. For example, R as repair. Repair, an action that today we no longer have to do, and it is not convenient. Sometimes it costs less to buy anything. R as refuse. We must reject behavior that we don't find correct. And then R as rethink. Change habits and attitudes for a more rational consumption. And then I can also add another R. R as responsibility, responsibility of everyone. In 1987, Bhutan stated that the sustainable development is a development that meets the need of the present without compromising the ability of future generations to satisfy their own, as known. I think it is a very important statement, but we must update it. Sustainable development must guarantee our service, not only future generation, the current resources. So I think the sustainability is offered today, is now. Now the second question, who introduced the circular city? The 24th Agenda for Sustainable Development is an action program for people, planet, and prosperity signed in 2015, you know. The role of cities, regions, and local authorities are very important. The agreement recognizes the role of different stakeholders. The 2030 Agenda considers 7 goals. Each goal has a specific targets to reach in the next 15 years. For a circular city, it is very important, the goal 11, making cities and urban settlements inclusive, safe, long-lasting, and sustainable. Includes a series of sub-objectives that are directly linked to a circular approach at the urban level. Other goals are important to circular city. For example, I report in the slide goal 12 about sustainable production and consumption models, or
Francesca, we lost you. You probably
lost you.
Yeah, you have to unmute your microphone. You need just to unmute your microphone.
Okay, sorry.
Yeah.
Okay. I'm sorry. Okay. A moment, please. Okay. Goal number 7, to ensure access for all sustainable and modern energy system. And the last goal 13, take urgent measures to combat climate change. In 2016, following the 2030 Agenda, urban agenda was introduced, the United Nations conference in Quito drew up the new urban agenda. It contains guidelines for making cities more inclusive, greener, safer. The urban agenda presents 3 commitments aimed at achieving the global objectives of the new urban agenda. The first is realize the new urban agenda to the European urban agenda. The national plans for the 12 priority themes are being developed. The second, develop a global and harmonized definition of cities, elaboration of database, a list of cities and their characteristics. And the third, promote cooperation between cities in the field of sustainable development. The connection between urban agenda and the circular city is very, very important. As a part of the European urban agenda, a partnership on a circular city has drawn a draft action plan whose action are better regulation, for example, make waste and the water management legislation to support the circular economy in cities, another better financing, prepare a circular city finding guide to help cities access funding, and better knowledge, for example, develop an urban roadmap for the management of circular resource. Now, the third question, what is a circular city? Cities are protagonists in the global transition towards a circular economy. You know that cities are the center of consumption, but also production, innovation, and economic social relation. The circular approach defines the management of inputs and outputs. The participation of different stakeholders and the definition of a shared strategy are the key elements in this project. A circular city is characterized by different elements. For example, building design in a modular and flexible way, or the accessible economic and clean urban mobility system. It is important to introduce the concept of urban metabolism. It identifies complex networks of social and physical infrastructure interconnected to each other. So the city becomes a living superorganism in which there are continuous flows of inputs and outputs. There are 2 fundamental aspects for a circular city. The first is participation. Participation among different types of actors, public or private. And the second is the use of ICT tools, information, communication, and technology. Regarding participation, it is important to remember the first document that was based on this concept, Agenda 21, introduced in Rio de Janeiro in 1992 as known. Agenda 21 identified the tool to combine the environment, economic and social development through the sharing of medium-long-term scenarios and the assumption of the responsibility of all social actors. Different stakeholders has been put around the table. The role of population is fundamental. There are 2 types of participation: horizontal participation between homologous roles and vertical participation with actors belonging to different levels. In this slide, I report the concept of ILEX, which represents the importance of participation in the planning and the management choice for a city, for a territory. In the triple helix, we have public administration, research, and trade. In quadruple helix, we have public administration, research, trade, and population. In quintuple helix, we have public administration, research, trade, population, and organized civil society association. Thanks to the involvement of different actors, a collective intelligence is created, and it is fundamental for the safety, sustainable, and resilient development of a city. This approach allows for the creation of a society with a greener ability to act. Thanks to the concept of participation and the concept of the quintuple helix, we can introduce another concept, the concept of open governance. In the circular model, the citizen is very important. A person lives in the city and the city is designed around him. So the circular city is an ecosystem. To function requires the contribution of all its protagonists. The priority themes in cities are different. Themes of the circular cities are, for example, circular economy, urban regeneration, green and blue infrastructure, sustainable mobility, technology innovation, resilience and climate adaptation. The second important aspect for a circular city is the use of ICT tools. In the slide, I report some example of circular action that have been carried out in the city of Northern Europe. And in Amsterdam, the solar project was aimed at transforming Dutch public roads into a real resource of clean renewable energy. In fact, a first section of a two-way cycle path was repaired with rows of solar cells. Another example is in Copenhagen, and using intelligent traffic system, the roads turns static from dynamic. The LED lights in the asphalt indicate which form of transport and has priority and when. Here are the example of circular approach, actions, and the use of ICT tools. In the first case, an example of circular, but also resilient action is reported. The city of Copenhagen suffers from torrential rains. The creation of cycle paths with modular and light panels allows water to flow inside. So through redesign of mobility on bicycle, they're able to solve problems related to save against the floods. In the second case, I report the lighting of the municipality of Copenhagen. For example, replace historic luminaires with high pressure sodium lamps on residential street, or implement smart city solution. An example of a circular city is Amsterdam, called Circular Amsterdam. In the city, planned and developed policies and action are different. For example, the investment in clean energy and electric vehicles. And also in Amsterdam, 98% recycled to strip in the asphalt is used to create a cycle path. In this example, you understand how recycled waste is not only waste, is not a waste, but it becomes a new material, a raw material to build a cycle path in the perspective of the circular economy, closing the cycle. So it is very important, this concept. the close of the cycle. The Circular Cities Declaration is recent, and I report the website for other information. Here I report what a sustainable city is, already described by the colleague Professor Pezzagno, and the relationship between different concepts for a sustainable city. A sustainable city is a circular, resilient, smart city. Circular city is a urban system designed to regenerate it. Smart city uses ICT innovation. Resilient city faces external events and it is able of adapting. Now, the fourth and the last question. It is possible to transform our cities into circular cities. Yes, it's not easy, but it is possible. Thanks to 23rd agenda, you can have the transition from circular economy to circular city. How? I think by different way. For example, by definition of new tools, by the introduction of a circular indicator, circular action, and by review of existing urban planning. I think it is very, very important, the last point. So the works are in progress, transforming our realities into circular cities possible by involving the different stakeholders for a shared strategy. Now we are few, but later we will have to be many. Now, in conclusion, in this slide, I report the architectural, engineering, cultural area of the third curriculum. Professor Brunetta, Professor Tira, Professor Pezzagno, and me, and the research programs that will be developed in the first PhD cycle. So thank you very much for your attention.
Thank you, Francesca. I wanted to say that we are a little bit in delay. It's my fault because I have problems in starting. Go on writing in the chat and follow the comments, please. And now we have the presentation. I think that Alessandro Capra will start, and then Giovanna will join. And the topic is sustainable management and monitoring infrastructures, environmental and water resources in the changing climate. Alessandro Capra, okay, you are there. He is full professor in geomatics in the University of Unimore. And more recent researchers in geomatics. He has done research in geomatics, and he has focused on monitoring and underwater surveying and change detection. He is the coordinator of the Italian Geodetic Observatory since 1999. So he isn't young, and he has a long experience. Please start, Alessandro.
Thank you very much, Michelle. Overall, thank you for young. Thank you very much. Okay, good morning, everybody. Thanks to Michelle and all the organizers of this seminary. I share my screen. Okay, here it is. I hope it's okay, right? And regarding this, coming back, okay, right? The seminary or the intervention are two, by me and by Giovanna Grossi from the University of Brescia. She will talk overall about water resources and everything on the sustainable management of water. And my intervention, my topic is more related to monitoring, deformation monitoring. So it means measurement for to control infrastructure, environmental, even water resources, and every kind of environmental artifact and manufacts. So I would like to take the attention on deformation monitoring. So for this, obviously, it's a particular topic, particular argument in the topic of the PhD, but it's important regarding, I want to point out the attention regarding measurements. So just in order to manage the territory, the structure and the infrastructure, is very important to evaluate the change detection applied to structure, means buildings, manufacturers, and so on, infrastructure, and even natural environments like instable slope, landslides, glaciers, and so on. So I would like to talk about measurements, so instruments and methods, just in order to evaluate and to control the deformation and to monitor it. And it's very important to talk about different instruments and methods, because it's very important the integration approach, just to verify the potentiality of instruments and methods, and to cross-check the results, just to have a more robust solution. And in this presentation, obviously, I have no time to go deeply into detail about the characteristics of instruments and methods, the data processing, and so on. But I would like to give you some flash, some point, and just in case to answer to your question, and to go to fostering more details in some other approach. Yeah, first of all, some principle. These are very basic, but I think in this case, for all of you, it's important to point out the attention on this particular. What's the difference between surveying and monitoring? So surveying, it's a single step. When you define the object coordinates, you determine the object coordinate, and you define the geometry of a system. The concept of monitoring is to control in time, so determine in time the object coordinate of your system, structure, and so on. This is a very important question. You cannot define to have a monitor a situation with only one measurement. Obviously, you need measurement in time, different step, made by periodical or continuous measurement. It depends on the object, depends on the risk, on the cost, and a lot of particular, but it's very important to take care about the continuity of your measurement in time, just in order to monitor a situation. And for this, the discipline are different. And nowadays we talk, or we call geomatics, but we have geodesy, applied geodesy, topography, photogrammetry, remote sensing, different instrument and techniques. And regarding the data acquisition, then you have to represent and interpret it through mapping, digital mapping, GIS, and BIM. Please, GIS and BIM are not instrument for monitor, because are not instrument to measure, but it's a way to represent a complicated way, sophisticated way, but it's only a way to represent what you previously measured. It's very important in terms of concept. Some people say, okay, I monitor a phenomenon through a BIM. It's not true. It's only a way to represent, but you have to measure it. Then a very important question is related to the reference system. To monitor, we have to control a system, a geometry of a system in time, and it's very important if we have to determine, coordinate which reference system we are referring to. So it's very important to have an external reference system, stable one, stable by the point of view of geological approach, geotechnical approach, and so on. And so it's very important to define, obviously, an internal system, but even an external system, a so-called more inertial system. It's very important to define this system or to measure the stability of this system. So it's important to verify in time the reference system stability. Obviously, if I have to control the coordinate, I have to be sure that the reference system will be stable in time. It's another very important question, and you have to take care when you analyze some data and you have to process some data. Okay, now a very few example of terrestrial geodetic techniques. We should use total station, we should use leveling, laser scanning, and for example, GNSS system. Here you can see different example of GNSS network for monitoring, and the system for monitoring are GNSS geodetic system. And for example, on the left side, geodetic network in Friuli, Venezia Giulia, just in order to control the deformation, the crust deformation. Up on Sumatra, big network established after the tsunami that happened, unfortunately, in 2004. And this is a network to control geophysical and natural hazard phenomenon. And for example, on the right side, above the right side, the network established by international INGV for the geodynamics control of Italy. So this network is, in this network, the GNSS system are acquiring continuously the data, and the result are a geodynamics control of Italy. So an example of large scale monitoring. Then another example for a regional network, 700 for 300 kilometer extension in Antarctica, WLNF. Here is the area of Antarctica close to the Pacific sector, eastern part of the Ross Sea, a network of 26 points. This is an example of GNSS permanent network close to the Italian base. This is the connection of this network to the southern network made by USA. This is an example on, what does it mean? We should control in a regional network, but through the connection with other network, we should extend the control. In this case, we are controlling the deformation network of Antarctica, and we control the movement between Antarctica continent with the peri-Antarctic region. And we should, for example, extract through the residual velocity of horizontal distance processing, we should extract the rigid crustal blocks. This is an example of geological or neotectonics interpretation. Okay, another example, integrated system for landslide monitoring. This is a particular landslide in the northern Apennine in the Modena area. The risk of these landslide are due to a breach located at the bottom of the landslide and a gas pipe on the top, on the crown. This is an example what we want to mean. Every kind of intervention in terms of sustainability is to be done with respect to the risk. If the risk is very high, we should proceed with to monitor an area. If the risk is not so high for man, for the people, and for the manufacturers, obviously we can only make an overview and not to start with a monitoring step that is cost and time consuming, obviously. In this case, we establish with two master stations, GNSS and the automatic total station. These are the point measuring along the landslide, the different kind of installation, the marker on the landslide with a stake, aluminum can, and with a permanent rover station. So it means with a permanent acquisition on the landslide. And the results are the flux, so are the study of the kinematic of the lens line, and even the data in real time. Obviously, we should establish like a threshold, so an alert system, just in order to control, to monitor the event. Another example, the subsidence study. This is the case of Ghirlandina Tower, located in the UNESCO site of Modena. Through the vertical displacement movement, we should establish the subsidence effect on the structure, the Ghirlandina Tower, and even to establish the differential effect, this should be dangerous in terms of structure stability. And even in this case, a very important thing I wanted to point out, the integration between the instrument and the method, having the cross-check of the result. In this case, the pendulum measurement coupled with the leveling subsidence monitoring. Another question, not only geomatics or the instrument from geomatics, but even geotechnical and structural sensor, which we should integrate: extensometer, pendulum, joint gauge, clinometer, distanceometer, accelerometer, so geophysical instrument. And an example of this application to the monitoring system of the two towers in Bologna, Asinelli and Garisenda, is a real-time monitoring system with, in addition, a gonionemometer and some other instrument. Here are the location all around Garisenda and Asinelli, and the system should permit even having real-time monitoring data. We should have an alert system just in order to verify the risk for the structure. Then another very important field, the high-density 3D reconstruction through LiDAR images, and with the terrestrial LiDAR, and we should use LiDAR and photogrammetry through terrestrial measurement through the drones and the flight drones. Using laser scanning, for example, we should make a diagnostic of a stratum. In case of a Ghirlandina Tower, after the 3D model, we should establish the height of the Ghirlandina Tower, and through the section analysis of all the 3D model, we should establish the physical behavior that are interesting in terms of structure diagnostics and structure monitoring. Then, for example, another case, using the 3D images, so dense images from photogrammetry, we should
Sorry, Alessandro, we lost you for 10 seconds, so probably the connection went down. So if you can repeat just when you... Yeah, thank you. No, we cannot hear you. There is the problem with the connection, probably. Wait a minute.
Okay, I come back. Can you listen?
If you want to switch off your video
I try. Perfect, I come back.
Try now.
Now? You listen?
Yeah, go ahead.
Okay, I'm going to add. Okay, can you listen to me?
Yes.
Perfect. I talked about another approach, so image density acquisition through laser scanning and photogrammetry, and I show you some example. In this case, you can control the leisure and fractures on a wall. I show you some other example later. In this case, using, for example, terrestrial photogrammetry in continuous acquisition, you should define on a query face the material in case fall down from the rock in time. Obviously, you can make it through different epoch, and you should compute the material, and you should compute in case the risk for a quarry excavation, or if there is a wall incoming on some manufacturers and so on. Another example in our case, it is interesting because it's a combination of deformation monitoring and an application very important for the climate change evaluation. We made a study, underwater study on coral. In coral area, it's located in Moorea Island in French Polynesia, and we made measurement through high accurate photogrammetric underwater measurement on some sample area, just in order to detect the coral growth and
you're down.
Coral, please.
We are not able to hear you.
Okay. I change, sorry. I try to exchange my net. Now is better, Michelle?
Yes.
Okay, I change the network. I hope the connection should be okay. Okay, can you see could you see the?
Yes.
Okay, in this example, we made underwater photogrammetry. We made a reconstruction on a 3D surface, and through the comparison of the surfaces, we should detect, obviously through the analysis of 3D models with different section and profile, we should understand how the coral was growing, the red and yellow color, and where it disappeared. Why it's important? Because through this sample of an area and through the interpolation of the different area, we worked on the French Polynesia, but our measurements are included in an international network controlling the reef growing, and through all the data, it's possible to define the effect of the water physical parameter, it means temperature and so on, and to have some measurement, some control of the climate change, because as you know, the growing up of the coral is strictly related to the climate change. Is an example of the link between local measurement to global measurement and to global study effect. This is another example on glacial monitoring. It's one parameter important. I think that will be important even for Giovanna Grossi next presentation regarding the kinematic GPS using the kinematic analysis of glacier thickness and the use of INSAR techniques. Another way to study the glacier monitoring is through continuous photogrammetry, dynamic photogrammetry, epoch by epoch, just in order to understand the dimension, the ice melting, and the geometry variation of the glacier. Finally, some notes on interferometric SAR techniques made by satellite, from where it's possible, as you know, probably to define the elevation map, the deformation map on some volcano, line coast, and so on. These techniques has been a very large development in the last 30 years, and it's possible even to use ground-based SAR to analyze, for example, a displacement map on of a landslide. I know that I'm going very quickly, but it's just in order to give you some idea. Then through the INSAR, it's possible to study the post-eruption deformation of volcano, the subsidence monitoring. This is an example of the plain close to Bologna and Pianura Padana plain, making or controlling P-point scattering, so point located on some manufacturers all around the area. You should determine with an accuracy of few millimeters the subsidence effect, and you can study even the coastal subsidence. And with the same system, it's possible to control structure or infrastructure. for example, to monitor a breach and to monitor structure damages like leisure and failures on structures. Obviously, it's possible to use this system, remote sensing active system, in integration with the terrestrial and photogrammetry and laser scanning too. One note more on the very important IoT application, so the automatic system for deformation monitoring. With nowadays technology, is possible to connect all the sensors and to make a real-time control of extractor. Okay, thank you very much for attention, and please do not forget the measurements, the importance of the measurement before making any kind of analysis. This is my witness for this day, and I am available obviously for your question and just for every contact you want to do in time with me and my group. Thank you very much.
Thank you, Alessandro. Stop sharing screen and Joanna will start, I think.
Okay.
Joanna Corsi is associate professor of my university and in the hydraulic research field. So I leave the floor because we are in delay.
Thank you. Can you hear me, first of all?
Yes.
Can you see my screen?
Yes.
Okay, so I can start very quickly talking about glaciers, since the very interesting presentation by Alessandro Capra also mentioned the glaciers. And this is a beautiful picture taken of the Mandrone Glacier, which is the largest glacier unit on the Adamello Mountain a few years ago, though. Why are we interested in glaciers? Because they are mainly a precious storage of water resource. Let me just recall the water cycle. I know that you all know what I'm talking about. Just to recall some of the processes, let's start from the oceans or the sea. The water is going into the atmosphere through evaporation. In the atmosphere, you have the water vapor. Part of it will generate through different mechanisms, precipitation, which will fall on the ground. Precipitation can fall as rainfall or as snowfall. If it falls as rainfall, then this means that it can immediately run on the hill slope and reach the river network and finally reach a lake or again the sea and the ocean. If it falls as snowfall, then it remains there for some time at least. So the availability of this water resource will be at least delayed in time. And then both rainfall and the melting, the product of the melting of the snow cover or the ice cover can partially infiltrate into the soil deeply to feed the groundwater storage or just in the first layers of the soil, so that it can soon have the opportunity to reach back the Earth's surface through springs and so on. But this means that it will be available again with some delay. So all this is actually a matter of space and time, and on the features of the surface of the Earth, and on the features of the specific site that you're looking at. And one of the variable which is strongly correlated to the let's say water availability and for vegetation especially, is the soil water content. And the soil water content is changing in time according to seasons, and also is changing in space according to also the different climatic features of the geographical site. This image is showing you the dynamics of the soil water content with respect to the season, changing in time through the months, and also is showing you how this is strongly correlated with the climate of the site, which is also, as you know, strongly correlated to the latitude of the site. But then let's go back to the glacier, because this is something that we need to, this is an analysis that we need to perform if we want to have an idea of the availability of the water resource, even of the water resource which is stored in the glacier. So let's go back to this Mandrone Glacier. You see it here in this map. This is the shape of this glacier unit. It is in between the two regions, Lombardia and Trentino Alto Adige. It is located at a high elevation. What do we need to analyze the dynamics of this glacier? The most effective tool that we can have, that we can build, is a mathematical model. A mathematical model of the natural system. And this mathematical model, of course, has to take into account all the features of the site, of the glacier, of the surroundings, and also has to take into account the meteorological conditions that actually rule the dynamics of the glacier. So here are listed the meteorological variables that are helpful in understanding the dynamics of the glacier. For example, shortwave radiation, air pressure at the surface, wind velocity, air temperature, precipitation, specific humidity. All these variables are actually monitored through different ground monitoring stations. These ground monitoring stations sometimes are available, sometimes not, in the surroundings, maybe of the mountain area that you want to look at. And most of all, these are point measurements. Then there are other features that we need to know about the glacier. And for these features, it is very helpful to know the spatial variability of the feature. And this is where the remote sensing is supporting the analysis. For example, if you want to check the extension of the glacier through different years, satellite images, the analysis of satellite images can support you. And this is an example of a satellite image which was used to estimate the extension of all the glaciers on the Adamello Mountain as it were in 2003. So let's go to the next slide, which is actually a representative of the information that you can get through also remote sensing through images. And this image is showing how the glacier has changed, how the extension of the glacier, the area of the glacier has changed through centuries and decades. Can you see this blue thick line is actually showing the place where the glacier was in the 19th century during the Little Ice Age, and then how it has retreated through time. And if you look at this red line and the green line, these are two different satellite images, Aster images, the red line in 2002 and the green one in 2003. And this is showing how the tongue of the glacier, which is actually the part of the glacier which is located at the lower elevation, which is also the one where the retreat is more evident. So, for example, comparing this information, you can have an idea of how much the glacier has retreated in 1 year. And also here, what you can see here is the result. Can you see the full screen?
Yes.
Yes.
Okay. Just no. Okay. So mathematical models. What can tell you mathematical models? Can help you understand the availability of this water resource located in mountain areas. And this is a result that we could have through a mathematical model of the fluid mass, which is the glacier. The glacier is namely a mass of fluid. And the mathematical model, through the mathematical model, it was possible to check the average annual mass balance, spatially distributed over the area of the glacier. In this picture, you see that the different colors point out the different amount of actually mass loss that occurred on average every year on this glacier through this period of 15 years. So if we look again at the tongue of the glacier, this is the one which is, this is the part of the glacier which is losing more mass each year. The orange color, just to give you an idea, means that the mass balance has been in between 3 and 4 meters of water equivalent. Now that you have this mathematical tool, then this is something that you can use also to check what could be the dynamics, the behavior of this natural system in different future scenarios. And so you can consider the climate change in this analysis. And this is an image that I want to show you, namely to let you reflect on the different spatial scales that can be considered. What you see here is the grid of a regional climate model. I think you have heard about these also in previous webinars. So this is the size of a grid cell. Just for those who don't know, here is the town of Brescia, right in between the Lake Iseo and the Lake Garda. The Oglio River is upstream of the Lake Iseo, and right there, this very small white spot is the Adamello de Mandrone Glacier. So first of all, you see that there are different spatial scales involved in the analysis you can carry out, both at the basin scale of the Oglio River, or even more focused on the glaciarized area. So you can account for the result of the climate models. So for example, to check what could be the availability of water resource in the river. That is the runoff, the flow in the Oglio River. And this plot is showing the difference among the precipitation in dark blue and runoff in dark brown, as it has been observed on the past period starting from 1980 up to the end of the previous millennium. The difference since the difference among the observed let's say flow regime, which means the average monthly flow, and in the other shadowed bars, so blue is for precipitation and brown again is for runoff, what you can get if you consider different climate change scenarios. In this case, the climate change were those like A2, and we will see for the glacier, we have been considering different climate change scenarios. But in any case, what you see is that there is a shift in this water availability in the different months. And this is the effect of the different climate scenario that you are considering. So the mathematical model is a very precious tool to analyze the availability of water resources. When we focus on the spatial domain of the glacier, this is the result of the analysis concerning the mass balance of the glacier in different climate scenarios, in this case B1 and A1B, at the middle of this century and at the end of this century. Again, you see that the tongue of the glacier is the most vulnerable part of the glacier, of course, and very dramatic is the projection of the extension of the glaciarized area in the different climatic scenarios and at different time horizons. This is the worst condition, the bottom right one, which is, let's say, at the end of this century in considering A1B scenario. So the glacier is expected to more or less completely disappear. But then we have been proposing also for you this reading of the report published by the Environmental European Agency right at the end of 2021 concerning water resources across Europe, confronting water stress, the assessment of these water stresses. So first of all, by water stress, here it is meant either drought or water scarcity, or an issue with water quality, like bad water quality, or an issue concerning water accessibility, like water is not so easily accessible. You can have a look at the report. There are some highlights here also written. The water stress affects 20% of the European territory and 30% of the European population. Southern Europe faces severe water stress problems, and the key pressures on water resource availability deal with agriculture, public water supply, and tourism. There are also good news. The good news concerns water use efficiency, which has increased in agriculture, electricity production, industry, mining, public water supply, and tourism, and also that the legal framework has been set promoting action to reverse water scarcity and drought. And this legal framework consists mainly of the so-called Water Framework Directive published in the year 2000 by the European Union, and also in the updated strategy on climate change adaptation. And what are the future prospects? So what do we expect for the future? Again, according to this report, droughts are increasing in frequency, magnitude, and impact. There is some way also, again, this good news, improved water use efficiency could deliver a further reduction in water abstraction, which is something which is, let's say, impacting the natural water cycle, of course. But on the other hand, this improved water use efficiency will not avoid the climate change impacts on rainfall-dependent natural systems and on agriculture, and will not avoid strong local increases in water demand. And these strong local increases in water demand are expected also because of the urbanization and the increase of the population which will live in cities. A warmer and drier climate also will increase irrigation requirements. So all these new challenges will face Europe, and especially Southern Europe. But let's say that both the two, let's say, legal tools that I've been mentioning and all the European policy has been recently promoting public engagement, societal engagement, engage stakeholders in also in the decisional processes, but engage the society and local communities also in research projects. This is the reason why through a European project called SciShops, a science shop was started at University of Brescia. The name is What Shop, and you can visit the website if you want. And this science shop is what is called a community-based participatory research initiative, fostering the engagement of local communities in the development of research projects. And this science shop is focusing on sustainable water resources management, control and consumption. So addressing many sustainability issues concerning water resources. And I would like to finish mentioning one of the research projects that What Shop was dealing with recently. The name of the project is Dico la mia, which in Italian means I want to say my word, I want to express my opinion. And the project was coordinated by Ambiente Parco, which is a social enterprise located in Brescia and managing actually a water park area in the town. The project was aiming to promote communication and awareness on sustainability issues, also concerning water resources management among young citizens, including high school students, university students like under graduation, but also PhD students. So I want to leave you with this message. You are PhD students in this PhD program on sustainability and climate change. And my message is be engaged and also promote local communities' engagement in the research activities that you will carry out. Thank you.
Really, thank you, Giovanna. So the last presentation will be done, will be on modeling of decarbonization scenarios, building and territorial analysis. We have two speakers. One is Mario Motta, and the second one is Marco Manzan. So they are two associate professors. I don't know who will start. Mario Motta, okay. Mario Motta, he is from the Polytechnic of Milan, and he works on solar energy systems, while Marco Mazzani is he is an associate professor from the University of Trieste, and he is working on heat transfer using numerical and experimental methods.
Okay.
Please start.
Thanks, Michelle. So I guess we are slightly late. So I mean, I'll try to be as fast as possible. So my aim today is to speak about modeling of the overall energy system with the aim of making assessments for decarbonization scenarios. So I'm going to give the first part of the presentation, and then Marco Manzan will continue with the second part. So I mean, the first introduction is that back in 2018, after the signature of the Paris Agreement, the IPCC started an analysis for understanding basically what are what is the context of application of technologies and how, let's say, our scenarios energy scenarios have to change to reach the aim to keep the temperature below 1.5 degrees. And what came out is it's a vast activity of modeling of the overall energy systems, which had to take into account all the different sectors of generation and use of the energy systems. And what I'm will try to do here is to define the institutional scenarios that we have been using that are available and actually are very much influencing the policy measures. So from the roadmap 2015 of the Commission to the local actions like national ones, to reach that target. So if you look at what happened in so last year, in the last months actually, let's say moving from what was defined in the Paris Agreement, which where it was said that the global average temperature would have been necessary to keep the global average temperature well below 2 degrees, and then the definition of the IPCC said, okay, well below means 1.5 degrees. We didn't have it in the European Commission documents, anything up to, let's say, the last 6 months, which was defining that our target was to keep, as the IPCC was saying, the global temperature to 1.5 degrees and then adapt our policy actions. And this happened back in 2021. And let's say the most famous actions that you probably already read, which necessarily required analysis of the energy systems scenarios evolution, are the ones which are included under the umbrella of the Green Deal. So the Green Deal objectives, and you probably heard about the Fit for 55 package, which is a package of measures, so directives and regulations, projects actually of directive and regulations, which the Commission released back in July last year, and that it is by now under negotiation with the union governments. It is pretty important because it's basically saying in order to reach that point, the final point that we were saying, so reach 1.5 degrees, we do need to be more ambitious already in 2030. And our targets will be to reduce the emissions, the CO2 equivalent emissions of the Union of 55% compared to 1990 levels. There are a lot of other measures in the Fit for 55 package, which I'm not going to discuss because it's not the focus of this seminar, but many of them are impacting the use basically of renewables, a vast use of renewables. I don't know, in the building sector, it is foreseen to reach 50% of coverage by renewables by 2030, or there is the introduction of an ETS system, so a carbon emission, basically a carbon tax system for the buildings, and many other measures. It is very ambitious. And let's say what is important is that any time that we set these targets and then we have to decide what we have to do to reach that targets, we do need to make simulations. So we do need to assess numerically how our energy system will work about. So, I mean, I'll give you some examples. Here is the EU Roadmap 2050, where the Commission basically said how we could reach the aim of being carbon neutral or almost carbon neutral by 2050. And this has been done by a modeling exercise of the Commission, which was showing us, for example, you see here, how the electrification of our energy system would be needed in any of the scenarios that are shown in this diagram. Actually, the two scenarios which are really respecting the boundary conditions to have 1.5 degrees at the end of global average temperature increase are the last two columns here, you see. And if you compare it with with the second column of 2015, it is pretty clear that basically our energy system has to change very much. Fossil liquids have to almost disappear. We need a vast increase of electricity, so a far wider use of electricity and basically renewables in general. Let's say all this picture here, it's again has been the result of numerical simulations of the scenarios. What is interesting is actually that if you look at, as well at economical terms, the different scenarios present completely different impacts. So the more is the use of technology instead of changing behaviors, the higher is the cost of the scenario. This is clear in the diagram that you see here. For example, the scenario which was pushing very much towards the circular economy, which is the red line, so reusing basically materials and energy vectors more than foreseeing investments only in pure technology, it's presenting a difference in cost of investment along the 30 years or the 50 years, which go from 2020 to 2070, which is pretty significant. It's interesting if you compare the orange and the purple curves, which are both two scenarios which are really reaching the complete decarbonization by 2050, that the two curves have got completely different investments. And this is mainly due to the fact that the 1.5 life, so the purple line, is a scenario which is reaching the target with a big change in the behavior of the citizens, not only using technologies. And this is having an effect, a significant effect on the investments which are needed. Basically, let's say the roadmap and the action lines of the roadmap are four. So we reach decarbonization, electrifying, having more efficiency, using massively renewables, and having a significant introduction of storages in basically all the networks which are used for the distribution of energy. I'm speaking, let's say, then electricity and thermal networks. If we look at the Italian situation, this is a diagram which is showing how the Italian energy system works. It is pretty detailed. I mean, in the presentation, you will keep the slides and have a look to all the different points if you want. What I wanted to highlight is that if the energy system, the actual energy system works in a way that on the left-hand side, you have imports of gas and oil, which are basically at the same, let's say, of the same order of magnitude for Italy. And there is the green part on the left-hand side of this diagram, which is renewables that get into the energy system. And we do resell refined, so we have exports of oil mainly and gas, which pass through the Italian economic system. But our actual demand is on the right-hand side of this diagram, and it's basically divided in three parts. As basically in every Western country with an industrial economy, the energy demand is divided in industry, transport, and mainly buildings. Let's say the actions which are foreseen for the application of the European norms and standard and directives, which force the introduction of renewables and efficiency in all these different sectors, have been, and let's say the policy measures that have been developed to reach the targets are based on modeling exercises. And I'm going to go through two examples, which are, let's say, the actual ones that are in force at the moment in Italy. And then I will conclude with saying what are the characteristics of the models that we could use the ones that we are using and the one we could use in the future. So if you look at the national plan, so the National Energy and Climate Plan, that Italy, as all the other EU countries, had to send to Brussels by 2018. We started our national goals, and we had reduction of GHG emissions of 33% for the non-ETS sectors and 43% for the ETS sectors. ETS means for the sectors where the emission trading system is in force. So basically the parts of the economy which are more intensively using energy. There was a target of introduction of renewables about 30%, so 22% in the transport sector, and an indicative 1.3% increase every year in the building sector, and 55% for the electricity. Let's say this basically forced us, let's say, in the scenario that we presented in the what we call in Italian PNIEC, this National Energy Climate Plan. There was a large investment in renewables for the electricity production, which turned up to be the most economical way to introduce renewables. This is the reason why it grew so much. And there was a significant effort on the energy efficiency with the introduction of building renovation and electric heat pumps. And in the transport, were appearing in this scenario about 6 million electric vehicles. Now, so this basically meant that in the actions, in the policy actions that are linked with the scenario, and we had a progression of, let's say, an increase on energy efficiency, as you see here in this diagram, continuously growing every year up to the point to reach about 9.3 megataps, so million of taps is tons equivalent of oil in 2030. And there is a continuous growth of the renewable energy share in all the sectors. Mainly, let's say, the one for the electricity, it's important. You see here the data of 2016, it was 34%. Nowadays is not very different. And it is necessary to reach 55.4%. Similar growth, it's foreseen for the share of in the heating consumption and on the overall gross consumption. Let's say the thing which is most evident is the necessary growth of the electricity share, so of the photovoltaic and wind share on the overall electricity production. If you see that, let's say, the efforts that Italy did from 2010 to 2011 show up to 2011 a significant growth rate of the installation for PV, which have been basically stopped in terms of new installations up to last year, actually up to this year. And it is now foreseen for the next 8 years a necessary significant increase of the installations, which shows then a pace of new installations, which is pretty similar to the one that we had with a very large introduction of the subsidies by 2010, 2009. The other exercise, which was the long-term strategy, and then I've got a minute to conclude, it's the long-term strategy. So it's the exercise that the Commission asked Italy to do for 2050. So basically asked us to make a plan to be completely decarbonized by 2050. And so even there, we had to use modeling exercises, which were taking into account our evolution path from today to 2030 with that targets that we were discussing, and the path up to 2050. These modeling exercises had a result that we basically had to reduce by 2050 40% our final energy consumption. So we need to consume 40% less energy. We need to have about 80% of the buildings which are renovated, completely renovated of the actual stock. A significant reduction of the number of vehicles, which basically means that people will not use anymore their autonomous car, but they will more and more use the public transportation. We will have electrification, which goes above 50% in all the sectors, and 85–90% of the coverage of our needs, final energy in from renewables. This is, let's say, the impressive figures are that we will be installing about 200–300 gigawatts of photovoltaic. So what we have got today is 20 gigawatts. So it's what is going to happen from today to 2050 is we are going to multiply for 10–15 times the amount of photovoltaics planted we have, and almost the same with wind. Last thing, we will need to introduce CCS, so carbon capture and sequestration technologies. I will conclude. I say that what I've been showing you are scenarios which are needed for institutional decisions, to take institutional decisions. And these scenarios are created using tools that are normally coming from, let's say, a long time experience of the entities which are working for the institutions writing the policies. They are not always the best instruments to do that work. Let's say the instruments which are mainly used for the institutional work are based on Times-Markle models, which have, let's say, a way of simulating the actual reality of the energy system that could be not particularly accurate if for simulations or for analysis where the renewable energy it's the large part of the energy system, particularly for where sources are used which are not programmable, so aleatory sources. And let's say there are some peculiarities of the system, the models used for the Italian case, let's say for the Italian policy and for the Italian political institutions that make me think that there is the need now for a new model and a platform which could be open source and therefore with a high level of accountability, and which could open up everybody the possibility to, or let's say to a larger amount of people, the possibility to understand what could be the evolution of the energy system towards the decarbonization. I am done, and I will hand over to Marco.
Here I am. Okay. Now I would fight in order to share my screen, as always happens. Okay, I started the presentation. Okay, and I share the screen. Okay, screen will work. Okay, could you see my screen?
No, it's arriving. Yes, here it is.
Yes.
You can start.
Okay. So I'm Marco Manzan from the University of Trieste. In this presentation, I somehow continue the presentation of Mario, but in this case, I focus on one of the issues that Mario already pointed out, is the problem with buildings and energy consumption in buildings. Here we have used a very known picture presenting the final energy consumption share in Italy, where we can see the civil use covers almost the 40% of the final energy consumption, far more than industry and higher than the transport sector. And when we speak about civil use, usually we are speaking about heating and cooling needs of buildings. So we can see that the need is very high. This is for Italy. And why this? Because this is because the buildings are very old. So we see that here this picture presents the year of construction of the buildings in Italy, Istat source. So we see that 86% of buildings have been built before 1991, and only less than the 3% of the buildings have been built after 2006. This is important because it's the year of the introduction of energy performance of building directive in Europe. The arrows that you see are the dates of the introduction of energy issues, energy laws in Italy. So we have the law in the 70s, then La Legge 1091 in 1991, and then, for instance, the energy performance of building directive that has been also presented in here, used here in Italy. But the problem is that it's not a problem only of Italy, because the same values are also shared in Europe. So we have for Europe, corresponding 85% of buildings constructed before 2001. And more important is that the buildings that now exist, between 85 and 95% will be also present in 2050. So all buildings will be still present in the future. But the European Green Deal says that we are going to reduce the emission by 55% in 2050, respected 1990 year. And to achieve this, is expected that by 2030, the European Union should reduce the greenhouse gas emissions by 60%, with the final energy consumption by 14%, and the energy consumption for heating and cooling by 18% compared to 2015 values that are figures, very high figures. With the problem that now in Europe we are experiencing a renovation rate of 11%, but the renovation are not focused on energy, because if we see strong energy renovations, these are only 0.2% each year, which means 60% energy reduction in this renovation. So the process is slow. So it's clear that the European Union is pushing towards a new wave for renovation. Here are some documents dealing with building energy renovation published by the European Commission. The first is the renovation wave, which focus in the problem of the slow renovation rate. And then we have other directives, Directive of European Parliament, the Council, the energy performance building. This is a new version. This is proposed right now in December 2021. And this one focuses on the on the fact that the directive, the now existing directive for energy performance of building must be somehow aligned with other documents of European Union. So, renovation is a key problem for reducing the emissions in Europe, but the renovation also brings key issues. Energy efficiency first. So the renovation has to have in mind that the energy is really important, and we only have to produce the energy we really need. So we must have a balance between energy produced and energy consumed. Important is the affordability. The system that can be proposed must be widely available between citizens. We must think about life cycle thinking in order to minimize the footprint of the building. So we don't have only to speak about how a building consumes for heating and cooling, but how can I reduce using materials with low footprint about the environment. And for sure, the carbonization integration of renewables, we have to focus on the introduction of renewables in buildings. And the other issue is the twin challenges and green and digital transitions. We have to push towards smart buildings. It is also important because if we have to link together different energy sources, we have also to optimize, and so we must have a sort of smart building with the building management system, evolved building management systems. And for instance, this is very important for Italy, respect for aesthetic and architectural quality. And I think this really challenging because some efforts that can be part on newer building cannot be adapted for older and very old building. For instance, external insulation can be used in all buildings, so we have to focus on internal insulation systems for some buildings with a lot of problems about the thermal bridges and so on. And then I highlighted this part, high health and environmental standards, because first we must guarantee the health of people inside of the buildings. So it's important to have high air quality inside the buildings without pollution. And also we must make buildings which protect the inhabitants against climate-related hazards. So there are a lot of building hazards that enter the buildings. The building must be climate resilient, and there are some acute and chronic climate-related hazards, for instance, temperature, wind, water, landslides, and so on. But these two say that climatic change must also be considered when we are thinking about the renovation of buildings. Increasing temperatures leads, yes, to a decrease of heating energy, but also led to an increase of required cooling for cooling energy. But also it's a problem for the high temperature inside the building. So some buildings that now can be during the summer have a temperature, affordable temperature for inhabitants, must be organized, we must install a cooling system in order to, in the future, in order to have temperatures, healthy temperatures. So just to present an example, here we have some projections about the locality of Trieste. Here we have heating and cooling scenarios. We have worked with some global and regional climate models, and here we selected some of these models. And here we we present how the heating degree days are expected to change in the future. So we see that heating degree days are reducing, or the climatic scenario review reduction of heating degree days, as I said before, with a lower consumption for heating. But if we see the cooling degree days, we see an increased scenario with an increase, therefore, for cooling, or for cooling energy, or for a decrease of the healthy situation for people. And then temperature is not only related to the consumption, but temperature is also related to health. And in this case, climate change increases extreme events hazards. In this case, I point out about heat waves. Internal temperature in this case may become too high, and with problems for vulnerable people, leading to social problems. We may be aware also the communities that with increasing heat waves frequency, there can be also social problems. Here we have a picture, a box plot that represents the distribution of heat wave frequency in each year. So the number of days included in heat wave with the different climate scenario pointed used before, and from today to 2100, and the different models preview different number of frequencies of heat waves, but we can see if the number is different, is not different the trend. So the increasing trend is common to all the scenario present. So it's important to deal with health inside buildings, and to have healthy buildings requires to take under control temperature, humidity, but also fresh air, and the possibility of removal and protection against harmful substances that can be used in building or renovating the building. The COVID emergency highlighted one problem, and the problem is the poor ventilation of buildings, especially institutional buildings. In particular way, schools and meeting rooms proved to be not resilient toward this new threat. To make a building safe against COVID, the better way is to use the ventilation, to increase the ventilation of the rooms, increase the ventilation of teaching rooms, and so on. But unfortunately, all buildings are not equipped with a system for guarantee ventilation. So we must think about also the system plans for heating and cooling, which must guarantee comfort, but must guarantee comfort with as low energy as possible. So for decarbonization and renewables integration in buildings, we have to work on a cooling system, and so I think it's a true challenge. So no new solution should be searched. In this case, I can point out the use of heat pumps for heating and cooling, switching from fossil fuels towards electricity with integration with renewable energy sources. Thermal storage, because we must guarantee that we solve the problem between the synchronization between availability from renewable energy sources and require heating and cooling. For instance, we have used the photovoltaic systems. We can plan the use of solar collectors, and as said before, air ventilation with heat recovering units. It's very important in new and renovated buildings, because the system can solve different problems. And then we have the optimization between all the systems, because we are dealing with a building that is not only made of walls and plant system inside, but are different plant systems. We have different energy sources. We have a different system that absorbs energy, and all the system must be optimized. So it's very important to carry on optimization between systems. So we must, in this case, have a system that can cope with the different behavior performance of different systems that are now inside the building. So the renovation of buildings, also the building, the construction of new building is really a challenge, because the challenge is to realize a resilient building energy design. This is also important because international standards are evolving in order to compute the energy performance of buildings from a monthly energy calculation that requires only a monthly temperature, monthly radiation, and so on, towards an approach towards hourly simulation. So we need hourly data, hourly weather data to compute the behavior of a building and all the systems that are inside. In this case, the new methods are more significant to solve cooling problems. If a monthly method works well for heating system, this is not so true for cooling problems, where the variability during the day is very important. And so we can see the hourly energy simulation tool to design a finished buildings and plants. In this case, we must design at the same time the building and the system plant. And also this is helpful for a smart integration of renewable energy sources, and especially to test how the plant control must be designed. Also, the availability of future weather data is a result in order to design a resilient building, because we must think not only about the performance with present data, but also we must test the performance of the system and the energy consumption of this system in a future environment where the situation can be very different from the present one. Thank you very much. I finished my presentation with this slide.
Thank you very much, Marco. I'm sorry for the delay. If you have questions, we can go on with the discussion. If you haven't got questions, I've selected the two from the chat in which you are chatting and discussing about our presentation. So please, if you have questions, can you stop the sharing screen, please, Marco?
Yes, yes.
Because I'm not able to see the guys.
Right now, because I've changed my.
Okay. Hang your hand if you have questions, please. I'm not able to see. Okay. I cannot see raise hands, so I want to only to reply.
I'm sorry.
I cannot.
I raised my hand. You may not have noticed that. Can I speak?
Please ask. Feel free to ask.
Thank you. I wrote my question on the chat box, but you may not ready. My question is for Professor Manzan. I was wondering, how can we install these technological systems when we have to deal with architectural limits or boundaries, for example, in churches or monumental buildings? Thank you.
Okay, I'm trying to. I'm fighting with the. Oh, okay. I go to have my mic disabled. For this is the challenge. I pointed out this problem, and for instance, not all the tools are available for all buildings. As explained before, if I'm dealing with a church, or if I'm dealing with a very old building used for in a municipality, for instance, I can use external installation system. I must use internal installation system. So I have to search carefully which is the best solution for the particular building. For instance, I'm not very, if I have to deal with a church, it's not a problem because the church is not used all the days, is not used the whole day. So in this case, it's useless to use a very expensive system and so on. But if I'm dealing with very old building used in a municipality and so on, I have to try to do as many as possible systems in order to reduce the consumption. But knowing that it's not possible to have a nearly zero energy building for this kind of systems.
So it's like finding a compromise.
It's always a compromise. And this is also true for historical cities, historical centers. For instance, it's impossible to have a nearly zero energy building for such environments, but have to develop some solutions, some new solution in order to reduce the footprint, energy footprint of those buildings while maintaining their characteristics.
Thank you, that's very interesting.
I want to add a thing on this topic, except for cultural heritage. There is a hard discussion among planners in relation to town parameters regarding buildings, because we have to change the rules for our cities in order to favor renovation, to make our buildings more sustainable, not only in relation to energy, but also in relation to the seismic problems. Okay, so there is a hard discussion on this in Italy.
Yes, for instance, I can agree with this because I think this is the real problem in Italy.
Yeah.
Okay.
Are there any other questions? If you are able to hang your hand, I want to reply only while you are thinking, only to question in the chat, because I think they are quite interesting. The first is was done by Gianluca Spadoni. He is writing. Good morning. Would you think? Why is the reason in Italian metropolis we are decades behind the others in relation to sustainable mobility? In Italy, you're right. In Italy, we have a lot of barriers. Several of them are relating to the concurrent regulations among national, regional, and local level. We must be aware that regulation rules we have, the old rules we have, and also changing rules, it needs time, and it's quite difficult. In Italy, mobility problems go beyond mobility boundaries and municipality boundaries. And we have two instruments. One is sustainable urban mobility plans, and the other aspect is that public transport managing is done, is not managed at the same level. This is a huge problem in Italy, and the results are, you can see the results, the problems in the metropolitan areas and in the metropolitan cities. Now, you know, we have legalized the administrative rule of metropolitan cities, and I think that in some we can see the effects of this strategic approach in next years. The second question was by Elena Alato, and the question was, it is possible to transform actual cities to sustainable, welcome also migrating population without consuming more soil? I think yes, in many cases it will be possible through techniques such as densifications and reuse of abandoned urbanized area due to changing in land use. The other aspect that you must take in consideration is that if you consume soil, you can also act in compensating biodiversity loss in the boundaries of the city. So again, we have to manage a complex situation, but we can, if you consume, we must compensate the loss. This is important. So if you have other questions, please hang out your hand.
I think there is a question in the chat about bonus energetico.
Yeah, reply, please.
Okay. What I think about bonus energetico, which one? There are so many bonus energetico. Yeah. It depends. I think that you are speaking about 110% bonus energetico that now drives the refurbishing of buildings. I don't like it, I say. I really don't like it because it's going too fast and without control. And why this? Because now we are lacking insulation materials, we are lacking tools, we are planned systems. The prices shown an incredible increase, 30% for windows, 30–40% for insulation materials. So we are running too much. I think the renovation of building has to be a progressive way of going on. If you have to renovate a building in 1 year or 1 year and a half, and so you have to run, we have to do a lot of paperwork, and so I think it's not the really it's not a perfect tool.
I want to add a thing about this after. Sorry.
Okay, no, only to say that we are going in the right direction, but I think that, and furthermore, I point out a problem, because we are doing renovation, we have some money from the government to do the renovation song, but we never do a check, energy check after the work. How is the consumption after the installation, after the installation of the heat pump and so on? I know about projects that took a boiler 1 year old and destroyed it because they installed the heat pump in order to have the financial aid. So I don't like it. Okay.
I want to say exactly the same, because there is a big distortion of the situation, because you think that you spend less, so you do things, and it's too fast, and it's totally reshaping our towns. And this is another aspect, without planning. And we are changing the image of the building and changing our morphology of the cities, the consolidated part of the city. And there will be a negative effect about this in time. And then the distortion is related to the economy and the prices. The prices of the materials are growing in an absurd way. And this it's a great problem.
There is also another problem, main work. Who's working on the buildings right now? People who started working on buildings 2 months ago or so. So the quality, I think the quality is very poor.
There is another question in the chat. Adoption of indigenous technology may be more useful to create sustainable cities in the developing countries rather than importing technology for the developed countries, which may not fit in their own system. What do the speakers think about? I agree with you. We have at our university, we have a research center on this research field. There are two main problems, I think. When you introduce you force the introduction of the technology, you have the main work problem. You have to, and the managing problem in time, and you can have also acceptance problems relation to the technology introduced by the society. The last point must not be undervalued. If the other speakers want to reply, feel free to do.
I think it's related a lot about what I said. I just said about the workers. If I don't know how to put on a wall insulation system, it's useless to install it. So if there are other methods known in a particular country, I think that these methods has to be, and there are workers able to use in a perfect way these methods. I think that's better to stick with those methods.
Okay, there is the last. Sorry.
I'm not an expert, but I'm aware of the fact that there is a chunk of studies on appropriate technologies, and so I think that there are obviously, let's say, the common problems and solutions which can be found locally using, let's say, technologies which are more appropriate for the socioeconomic context. For sure, there are certain technologies like the one that we were discussing before. One of the ideas, I think it was the Zeit, a very famous magazine in Germany, which back in 2011 to 2012 wrote that the subsidies law of Italy and Germany on photovoltaics, which enlarged very much the market and made the industry of the photovoltaic, which were producing the photovoltaic modules, far cheaper, and then made available photovoltaic modules at a far lower price in few years. That two subsidy laws have been the most impacting policy actions about cooperation with weaker economy countries, in a sense that they made available the technology in countries where otherwise, if the price of the technology would have been higher, it would have been impossible to use them. And so there is for sure a link. And photovoltaic modules, for example, they cannot be produced everywhere. You need a certain level of, let's say, sophistication of the industrial sector. But a mix of imported technologies and local available solutions, I guess, is the right way to do.
Okay, it's really late. I think we are all, we want all to go to eat. So thank you very much for your patience. And I want to thank all the speakers for their intervention. If somebody is missing in the reply, I will save the chat and then we reply you. Okay.